Data caching is a technique to improve the performance and responsiveness of applications, where frequently accessed data is stored in memory, a fast and easily accessible location, rather than a time-consuming operation like accessing a database. Distributed caching is when it is stored in an external service accessible by one or more servers. It is mandatory when you scale out and run more than one instance of our product. I'm showing the typical architecture for AWS, but it is the same concept on other platforms, and you can view their typical architecture on our product. Your cloud-native implementation handles adding resources by basically cloning the web service. Their out-of-the-box load balancer, such as AWS Elastic Beanstalk or Azure App Service, determines which web service the user's browser connects to as soon as you scale out. But when different browsers and stream hosts talk to any of the web server instances, the cached data must give the same result. In the example of an app page that is initially loaded, everyone will see the same published app page because it's saved in the database. When someone edits that app page, in order for every other user to see those changes near real time, those changes must be stored somewhere in memory that all the server instances access. With distributed caching, we move that in-memory data out of the individual web servers and into Redis. The end result is that the web server instances all access the same memory, allowing the clients connected to the different servers to see those changes in near real time too. There's a lot of functionality in our product that uses cached data. For example, streaming data from a stream host, or multiple stream hosts connecting to Application Designer, where the stream hosts are clients as well. The main reason for scaling is performance. For example, if the CPU was high for data streams and you had many streams running, you could scale up by increasing the app service plan in Azure, but there is a limit to how high you can go. This is when you would scale out to get more CPU. So one reason is for performance to scale up and out with demand. The second reason is resiliency. For example, if you had Data Stream Designer on Azure App Service Plan 2 and it had an issue where the performance was deprecated for some reason, users would be locked out. However, if you had two instances at a lower service plan and one of those had an issue that caused performance to be degraded, the users would be able to continue to use the product on the second instance. So resiliency is another factor. The third benefit is cost. Technically, you can auto-scale out and in again automatically or on a schedule to better manage your infrastructure costs in peak periods. Early benchmarking results indicate that using distributed caching has performance improvements even when you are running only one instance of the product, and so is something you may want to consider switching to for larger production-ready implementations, such as those with a large number of data streams.